For those of you who don't know me, which may include a whole mess of AppNexians, my name is Pete Emerson, and I'm on the Tech Ops team here. We're getting a little feedback on that? Turn it up a little bit. I don't want it to like blast your ears out or echo. Hello? Okay. We'll leave it there. Let me know if I need to adjust it. That's not good.
Speak up.
Speak up. So I'm on the Tech Ops team here at AppNexus. I've been here for about 3.5 years. And so I've been going through the explosive growth here, and it's been amazing. And what I'm going to talk about today are two technologies that I have had no experience with before this code that you're going to see today. So I do not profess to be an expert in either of these two technologies. The goal of this tech talk is to just show off these technologies, show you a little bit about what they can do, and then I've got some code up on GitHub to share if you want to take that and run with it. Help yourself. You'll see in the lower left-hand corner of the slide that this is proprietary and confidential. The sole reason for that marking is because I didn't want to modify the template. There's nothing here that is proprietary or confidential, so knock yourself out. I talked with legal. I was grilled by legal yesterday, and I assured him there's nothing here that he would want to patent. And that seemed to be okay with him. So the technologies that I'm going to be using for this tech talk, Python, which I have had no experience with up until now. I'm predominantly a Perl guy. GitHub, which I had no experience with because I use Subversion. Redis, I had no experience with because I use MySQL. And ZeroMQ, I didn't know what the hell that was, but I'm going to use it. So these are the technologies we're going to... I'm not going to talk about Python and GitHub at all, but they're there under the hood. We'll be looking at some, I'm sure, not very stellar Python code today, but really want to talk about Redis and ZeroMQ. So break the talk down into essentially 3 sections. I'll do an overview of Redis, what it is and what it can do, and then ZeroMQ, and then we'll dive into my parallel asynchronous command execution thing. I had to figure out some way to make a nice acronym, so there it is. So we'll start with Redis, and Redis is a NoSQL database, and as I had the project in mind when I was deciding what components to use, and so I started doing some Googling around for some various NoSQL solutions such as CouchDB and Cassandra and et cetera, et cetera. And I wound up with Redis, and I found this one reputable source of information. This is how I wound up with Redis. If you haven't seen this 5 minutes of YouTube video, note this URL. I tiny URL'd it so it'd be easy for you to see. It's worth 5 minutes of your time. It's wonderful. Go there and enjoy. So I had really no solid technical basis for choosing Redis other than it looked great and it was easy to install on my MacBook, and there we go. So the way that I think of Redis is it's memcache taken to a new level. Memcache being key value pairs, and Redis layers on top of that extra functionality. And so you can see the Wikipedia quote there, which is a little gobbledygook. So that's what they say. I say, think memcache with some extras. And I've been going back and forth pronouncing it Redis or Redis, so I did some research. It is Redis, so not Redis, Redis. Just like Linus Torvalds says, hello, my name is Linus Torvalds, and I pronounce Linux. There's a right way. So Redis, not Redis. For those of you AppNexians who have accounts on the general box, which is pretty much every single one of you, there is a Redis instance there that I've thrown up. So you can just telnet to localhost on that box, port 6379, if you want to play around with that. And if you want to play around with that now, that's fine too. Whatever floats your boat. And by the way, I should say, if you have questions as we go, feel free to just jump right in. I'm happy to do questions as we go instead of saving them for the end, so don't hold back. Okay, so let's talk about the Redis data types. We break that down into 6 different data types, and I'll explain a little bit about what each of those are with some examples. So we've got strings, and this is memcache equivalent, key value pairs. So in this example, I'm setting the value of my key to hello, and I can get that value and use it, memcache, right? Then we can kind of abstract that one layer and go and look at hashes. So we do an H set for this particular hash, and we're setting a field of the hash to hello. And then I can pull that value out as well. Redis has excellent documentation on all of the commands. I'll be showing that to you in just a little bit. I can get all of the keys of the set of the hash and print those out, and I can do some nice manipulations there. Redis also gives us lists. So I can push elements onto the list, I can pop elements off of the list. Those elements do not have to be unique. And I'm going to be using this in my code later on. One of the nice features of lists is that I can do a blocking pop off of the list. So I can have my code connect to the Redis server and just wait for something to arrive in a particular list, and as soon as that thing arrives, it will pop it off, and I can action on it. So it's like a queue, and I'll be using that in my code later on. Redis also gives us sets, so I can put things into a collection. Here I'm putting the words hello and world into my set called my set, and you can see I put world in there twice, but you can only be you're either in the set or you're not. So the second addition of the word world doesn't do anything. And then I can pull back the members of the set, and you can see it shows me hello and world. Redis also provides us with very nice set operations. So I can do intersection between sets, I can do unions of sets, and I'll show you that in just a little bit as well. In addition, on top of sets, Redis gives us sorted sets. So I can give a score that goes along with the set. And so here I'm setting scores of 1, 2, and 3 to these various members of the set. And then I can make a query which says, give me all of the members of the set whose score is between these ranges. Nice operations there. Finally, PubSub. So if I've got a mess of people connected to my Redis server, I can have them listen for events, and then I can push events out, and all of the listeners to the PubSub channels will get that. So we've got the usual subscribe and unsubscribe, and then on top of that, you can subscribe using patterns. You can subscribe to multiple queues. So let me jump over to the Redis documentation to show you, poke around a little here and then do a little demo. We've got, in my opinion, the Redis documentation is fantastic. It's a model of the way documentation should be done. And there's all sorts of great info about how you do replication between Redis servers and how you persist. Redis is by nature in memory, but then you can persist that information down to disk. So how you can do that and how you can tune your queries by pipelining them together. All sorts of great stuff here that's worth a read when you're just diving into Redis. But what I particularly love is the command list here is all laid out wonderfully. So at the beginning, I showed you the set notation there, and they'll give you examples here. But this is what I really like. It also gives you a Redis server right in the documentation, so you can then play with it right in the documentation.
Do you
So,
know if this is auto-generated? Is documentation generated by a tool that's available?
so the question from Urson is the documentation auto-generated? I don't know for sure, but I've got to imagine that it's all auto-generated.
Actually, I don't think it is. But
It's not?
There's actually a GitHub project that is the documentation. So you can submit pull requests in order to update the docs.
All right, so Dave Crawford says it's not completely automated, but it's up on GitHub, so you can make pull requests to it. So I think that's pretty slick to be able to just immediately play around with your commands right inside the documentation. That's great. Pardon?
The one on the web, is it really a Redis instance, or are they just emulating it?
I'm not sure what they're doing underneath. Like, for example, if you log in and ask for GET requests on keys that I've stored, I don't think you'll get it. And I know if I refresh the page, that data is gone. So I'm not sure exactly what they're doing underneath, but it is pretty cool. Yeah. So here's the documentation on set manipulation. I just wanted to show this off a little bit. So here's their intersection command, and you can see, so we're adding to two different sets, key 1 and key 2. We're adding A, B, and C to key 1, and C, D, and E to key 2. And then we've got this really nice intersection command that says, all right, give me all of the members of both sets. And answer comes back as C. And if I want to, I can say, all right, well, I'm going to add to key 1. I'm going to add B. Let's see what happens now. Oh, no, that's already in key 1. Let's add that to key 2. There we go. And now let's do an S-enter on key 1 and key 2. I should get both C and B right in line. So that's pretty slick. I like that a lot. So it's worth a bit of your time to just look through each of these each of the 6 different structures that Redis gives you and look at what you can do. The BL pop command here in the list is something that I'm going to be using in my code. This is that blocking pop that I mentioned. I'm going to be listening to a particular list for things to come in on the list, and as soon as I get something on that list, I'm going to pop it off and action on it. It's really slick. Any questions about Redis so far? Excellent. Okay, so let's talk a little bit about ZeroMQ. You may have done some work with other MQ technologies like RabbitMQ or ActiveMQ. I know we're using, I believe, RabbitMQ internally here at AppNexus for some things. And I'll say that the difference really boils down to ZeroMQ is a networking library instead of more of an application level component like RabbitMQ. There's no broker involved, and there's no network topology that's built into ZeroMQ. It's up to you as the developer of a ZeroMQ product to architect how your components are going to be talking to each other. And there you can see the bindings that ZeroMQ provides. Provides 12 different language bindings, some of which languages I've never even heard of. So probably your language is up here. I'm going to be using the Python language binding here, but here at AppNexus we do a lot of Perl, we do a lot of PHP, and all of them, and Node.js, right? Looking at you, Joseph. And so that's available for all of those languages. So we've got four different types of communications patterns that I'll dive into a little bit. We've got request reply, PubSub, pipeline, and exclusive pair. And I would say if you go to the ZeroMQ org site, I would not put ZeroMQ in the same category. I'm going to see if I can get rid of that. I would not put ZeroMQ in the same category as Redis as far as documentation, but the documentation is quite exhaustive, and if you want to learn about the internals of ZeroMQ and what's going on under the hood, it's very complete. They've got some great examples that you can download along with the source code. Examples in pretty much all of the languages that they support. They've got people who've been going through all of their examples and converting them into other languages. So that has been invaluable for me as a non-ZeroMQ consumer to quickly ramp up to speed and learn how to start using ZeroMQ. Okay, so let's look at these patterns here. So the first pattern is request reply. All right, and so this is, I'm sending you a message, you're giving me a reply back to me. Simple. Redis also, or sorry, ZeroMQ also supports a PubSub architecture. So we can have a publisher that's sending out the message once, and RSS feeds, chat rooms, example of good PubSub usage. And one of the beautiful things about ZeroMQ is that with very minimal code changes, you can completely change the underlying network transport that is being used. So for example, if you want to switch from your communications channel from TCP to UDP, minimal changes to your code, and when I mean minimal, I mean one line of code that you change in order to switch from a TCP protocol to a UDP protocol. And ZeroMQ is going to abstract the rest of that away into its library and just let you deal with your application instead of worrying about the networking complexities underneath. Okay, so the next pattern that ZeroMQ provides is a pipeline pattern, and the pipeline pattern, I would just give an example. So we've got a server that is handing out jobs, and the server just wants a pool of workers to connect to, and it wants to hand out something for those pool of workers to do. So you put the data onto the ZeroMQ, into the ZeroMQ pipeline, and then your workers are automatically round-robined, and whoever's next in the queue pulls the job off, and none of the rest of them get them, and everything is great. It does a round-robining fashion among all of the nodes that are currently connected. And finally, there's an exclusive pair pattern. This is really for if you're doing a multi-threaded type application, and you need communications between your threads, then the exclusive pair is the way to go. And I really don't know much more than that, so I'm going to leave it there. So let's do a quick demo of essentially Hello World in ZeroMQ. All right, so on the left we've got a Hello World client, and on the right we've got a Hello World server. And so I've just started up the client, and I'll show you the code in just a second. It's sending out this request, and it's not successful. There's nothing listening. So it's just sitting there hanging. And as soon as I fire up this server, then you'll start to see it go, and it'll send out, I think, 10 packets with a sleep of 1 in between each packet. Okay, so I just did request reply between two different applications. These applications happen to be running on my MacBook, but there's absolutely no reason that this couldn't be two completely different machines in our data center. All right, so let's look at a little bit of code. All right, so this is all that was involved in making Hello World, and this is actually example code direct from ZeroMQ. This isn't my code, it's their code, but it's a good example of some sample code that they give you with with the source. So essentially here what I've got is I've created a socket and I'm telling it to talk to localhost port 5555, and I'm sending out 10 packets, and after each packet I'm waiting for that reply. So I am blocking, and I'm specifically saying I'm doing nothing until the response comes back, and then I'll loop and send out more. And over on the server side, I've got an infinite loop here, and its job is just waiting for some data. And then it's acting on the data. In this case, it just prints out that it's received the request, and then it goes to sleep for a minute. So it's not actually doing anything terribly useful, but just demonstrating that some work is actually being done. And then sending back to the client saying, all right, here's my response, here's what it is. That response gets sent back to the client. The client says, I've received the reply, loop over and over again 10 times. All right, so there is a quick intro to ZeroMQ.
You have a question about that.
Dave.
You had like the socket, you were sending the socket to some constant here, REQ and REP.
Yes.
How does that change the data?
Right, so here I've got, on the client end, I'm making a request socket. And then on the server side, I'm making the reply socket. So this essentially boils down to who's communicating first in the chain. But I could have set this up to be, I think if I made this as ZeroMQ.push, then it wouldn't have waited for my client to respond. It would have just created a thread and send out a message and then go to the next iteration of the loop, and it wouldn't have waited for the reply.
So it changed whether the receive call blocks or not?
If I change from request reply to a different protocol. But as you're looking for the difference between the request and the reply, they're pretty much the same thing. Yeah.
You have TCP socket. What other protocols does it support?
So Larry's question is, what other protocols does ZeroMQ support? And I think I can show that here probably. Let's just take a quick look. But you can do by default you do TCP, but then you can do UDP and you can do guaranteed delivery UDP. So UDP does not guarantee delivery, but then it can do some error correction and ensure that your packet does get delivered. And then you can do in-proc, so you're just doing thread-to-thread communication.
Can you configure it easily to go in-house?
The question is, can you configure it easily to do multicast? And the answer is yes. However, the documentation talks a little bit about that, and it says, its advice is that don't do it until you actually need it. And the level of the networking here is so low and so fast that even at AppNexus with our thousands of servers that we've got, I'm not sure that we would move to a UDP transport. I guess one possibility would be if we wanted to use ZeroMQ as a file transfer, and then if we wanted to transfer gigabytes of data from one central place to all of our servers, then I could see where we might want to switch to UDP so that we could just hopefully transmit that one plus the error correction overhead, 1.5 times whatever that turns out to be. But the documentation says basically don't do it until you really need it. Other ZeroMQ questions? All right. So let's move over to the parallel asynchronous command execution script that I wrote to bring these two things together. So this code is available on GitHub if you want to check it out. That's Pete0mrc/commander. So take it, use it, steal it, but don't blame me if it breaks. So here's the architecture for what we're about to see. I'm going to start at 1 and go through 7. So my commander is where I'm going to execute the command that's going to be run on all of my clients. So the goal here is for me to get from one place, send out a message and saying, run this command, and then show me the results. And I want to persist that to my Redis database as well. So I want to save it forever so that tomorrow I can come back and say, oh, this job that I had run on these 500 servers, something went wrong. I want to look and see what went wrong. So I want to persist that back to my database. So my process will start with the commander, and I'll run a command there. I'll pump that data into the Redis database. I'm going to push it onto a list, and then my transmitter in step 3 is listening for jobs on that list to do. So as soon as something appears on that Redis list, the transmitter is going to pull it off and action on those items. So the transmitter's sole job is listen on the Redis queue, and then push that data out to all of my clients. On my laptop, you'll see in a second, I've got 3 virtual machines running on VirtualBox, spooled up by Vagrant, 2 more technologies that you should definitely check out. It's fantastic. So I'm simulating having a bunch of clients doing some work for me in steps for A, B, and C. When the processors are done doing what they're told to do, then they'll send their data back to a receiver. The receiver's sole job is to listen for those results and push those results back into Redis. And it's also going to push onto a list in Redis saying that, hey, this job is done. My commander is listening for those jobs, and it's listening for 3 jobs or however many jobs I've spooled off to be complete. And once that's done, it will print out the results, and the circle of life is complete. So let's demo that. Okay, so on the upper left-hand corner of the screen is my commander who's taking the data, pushing it into Redis, and I'm telling it to run this command on 3 different hosts, either my VirtualBox hosts on the laptop, and I'm also passing along how those processors should then talk back to the receiver. So I'm saying my receiver is located on 192.168.138.1 on port 9999, and the date command that I want to is what I want to run. So it's going to drop to the shell, run the date command, send the results back. So over here on the upper right-hand corner is my transmitter. I'll throw that into verbose mode so you can see all of this stuff flowing. Right below that, I've got 3 of my processors running, once on each of the boxes. I've hidden 2 of them down below because they're all going to be printing out the same thing and you need a little bit more real estate. Once those processes are done, then that data is going to be sent on to the receiver on the lower left-hand portion of the screen, who's going to store it back into Redis. And my commander back at the beginning in the upper left-hand corner is listening for those responses coming back, and as soon as it's got them all, it's going to print them out. Now, this is going to happen pretty fast, so don't blink. There we go. Okay, so we've gone from upper left clockwise around the horn, back up to upper left. It ran the date command on my 3 boxes, persisted that to Redis, and printed out the results. I think that's pretty good. Yeah, that's right. That's right, Ron.
Do you mind running that? Do you mind running that command and changing the IP address to a different address that it doesn't have?
You want me to change it, Urson, to an invalid IP address?
Where the receiver checks a little back to the result.
Sorry, I need that one more time.
That IP address, different port perhaps.
You want me to change this to an invalid receiver?
Yes.
Okay, sure. So I'll add a 0. Yes. That's what you want me to do. Okay. Now you can see over in the right-hand corner that scrolled just a little bit, and you can see it's sending this data. I decided to put all my data into JSON format. You can see it trying to send back to .10. Now, what has happened is that there's nothing there on 10 to listen to.
The reason I asked.
Sure.
Sure, cool.
Yeah, we're all done.
So you don't see that you have thousands of servers that you use. So how do you cancel it? You mean that you'll send another message and then perhaps listening on a different port? I mean,
Right. So Urson's question is your code robust? And the answer is no. So this really is proof of concept of what can be done with ZeroMQ and Redis, and is not an exercise in good programming in any way, shape, or form. However, what I will show you, and fly by the seat of my pants here, let's do this. I'm going to change it back to .1. So it's the proper host, but the wrong TCP port. So I switched that to 9998 instead of 9999. Now, what I expect to happen here is that over here on the in the processor, the processor is going to be just hung because there's nothing listening on 9998. Let's watch that. Okay, so we see here on the lower right, trying to send to port 9998. It's just sitting there waiting. Now, here's what I'm going to do. Code edit. I hard coded the port apparently. All right, I'm going to move my receiver over to port 9998. Let's see what happens. Didn't get it. See, I told you my code is not robust. Now, what I was hoping would happen is that it would pick that up and store it. It didn't, but in the real world it would have. Yeah.
No, over on the right, it's still loaded.
Over on the right?
Yeah, I mean
Yeah, I would have expected. So it's here. I'm trying to send to port 9998. I figured starting it up would let it go through. It didn't. I'm not quite sure why. Dave?
So ZeroMQ is between the transmitter and the processors, and then
So-
back to the receiver.
Right. So I'll explain where each of the pieces of technology come into play. Commander is solely talking to Redis. So it's pushing onto that queue and also pulling off the queue. Transmitter is listening for things to do in Redis, using ZeroMQ to transmit that data to the processors. Processors are using ZeroMQ to transmit that data back to the receiver, receiver listening on ZeroMQ, and then talking back to Redis.
So the transmitter and receiver seem kind of redundant to me. Aren't they just relaying?
The transmitter and the receiver are kind of redundant? Absolutely. Yeah, there's really no reason that I couldn't have combined those two functionalities into one and having the transmitter both doing the transmitting to the host and the receiving back from the host.
Oh, no, I also meant, couldn't the processors just do the subscription to Redis and write back directly?
Your question is, couldn't processors talk directly to Redis? Yes, they certainly could. That'd be an architectural decision. I'm not sure it'd be a wise architectural decision, because if you think about scaling up to tens of thousands of servers, you probably don't want 10,000 connections back to your database. You want to abstract that out in some way. And using ZeroMQ would let you do that.
So you can basically get better fan out because you have fan out to the transmitters and fan out to the processors.
Absolutely.
Okay, cool.
Yep. All right, so let me fix my code here. Let's make sure this works. Make sure my receiver is doing what it's supposed to do. There we go. Okay. So this is my first iteration of the code. All right, cool. Now I can run arbitrary commands on all my servers all at the same time, and the results come back. And just to prove that this is not fake, I could run any kind of command here that I want. So I thought, okay, well, that's good. Now, suppose that I want to run a script. Suppose that instead of just executing one shell command, suppose that I want to write some code and have some code execute on my clients. And I don't necessarily want to upload my code to all of my clients. I want it to just happen magically. All right, so let's see if we can do that. I'm going to use my favorite editor. And I'm going to switch languages here. I'm going to switch into some Perl.
Can you turn on coloring on that?
There's no color coding.
And now.
There is.
Line language perhaps?
No. You have to memorize every single line.
You can't count.
I am going to use strict, however. Good Perl programming practices. All right, and I'm just going to say, hello world, and try to spell things correctly. End of line marker. Save my file. Let's make it executable. And make sure I didn't make any silly typos. So there's my Perl script that I wrote. In reality, this would do some nice complex logic. It might be restarting a service and then doing a verification to make sure the service is up. Whatever, but let's do hello world. All right, so I'm going to change this to, say, code equals hello. Yep. And again, this will happen pretty quickly. But what has now happened is that the code itself has been read in, and you can see over here the transmitter sending that code on. You can see the Perl that I just wrote with nice backslash and end of line markers actually being sent over to the client. The processor is looking for either a code JSON entry or a command JSON entry. If it's a command, it just runs it as a shell command and then sends back the results. If it's code, it will save the code to dist in the temp directory and make it executable and then run it. And then collect the results and send it back. So I've got the power now to send any sort of arbitrary code and make a quick modification and send it again and it works. So from an ops perspective, I really like this power because I know that in the heat of the moment, I'm going to need to do something unexpected. I'm going to need to do something that I've never done before on my production environment, and I can't SSH to every one of our multiple thousands of machines and execute these commands. I need a fast way to do it. I need it now because we've got a problem that needs immediate addressing. So I like this because now I can write my Perl script, maybe run it on one machine to make sure that it's really doing what I expect it to do, and then I just say, okay, run it everywhere. Here's my code, sends the code out, runs it, collects the results back, and I'm done. Seeing head nods.
So that user has pseudo.
All right, so best coding practices. You run all of these daemons as non-root, and anywhere where you need privilege escalation, you're using sudo, and you've got an ACL list set up so that they can only run commands in certain directories, whatever. Once you open it up to uploading arbitrary pieces of code, and then you put on the requirement that you've got to be able to run this as root, which you may, then you've got to do your ACLs in a different place. You've got to do it so that no one can submit a command or job unless they have the authority to do so. Very dangerous to have this kind of power, obviously. There's no reason why, for example, they can't do something dumb like that, right? Or even worse. Yeah, not good. So you've got to have, I'll gently revoke that rm-rf/ to make sure that I don't do something dumb. Sure, you've got to have proper ACLs around something of this power. And the same thing applies to Maestro. And for those of you not familiar with Maestro, Maestro is our internal tool that allows our developers to deploy their code out to all of our various environments. And we have to have those sorts of ACLs in place so that you don't get to push code to wrong places until we decide we should be able to do that. Now, that may be on day one, but we have to have those restrictions in place so we can control that sort of access. Larry?
So you chose ZeroMQ because it's very low level and there's no application for running somewhere else to build their data. But, which is a very good benefit, but then you also lose some of those built-in magic into programs that you now have to build on certain standards.
Perhaps. What sorts of, so Larry's question is talking about ZeroMQ versus some of the other MQ technologies such as RabbitMQ and ActiveMQ, and what we might be losing out on by using ZeroMQ instead of ActiveMQ. I'm not terribly fluent with either Rabbit or ActiveMQ, but I do know that ZeroMQ does have built-in tolerance levels and will retry sending packets when it can't. So there are ways to guarantee that your message will get delivered. And then on top of that, you can also set thresholds in ZeroMQ. So you can say, all right, well, if this doesn't get delivered in a certain amount of time, or if the size of my buffer that is waiting to be sent grows above this certain amount, then air it out and do something else. So it's got a whole lot under the hood to provide that sort of redundancy. Because really, that's what we need. Is we need robust ways to communicate from point A to point B, or from point A to points A, B, C, D, E. And ZeroMQ gives that to us.
I guess one of the things is that, for instance, if you have someone just sitting trying to set up messages, it loads on your message to the partner.
Sure, but so there's always a chance that a component is going to crash. I would rather have a piece of my code crash than to be using, if you're solely trying to decide between RabbitMQ and ZeroMQ. My gut is I would rather write my code and use ZeroMQ and have it crash for some reason than to have my broker crash and have absolutely no clue why. But it's certainly trade-offs.
But it's in Erlang, so.
But it's an Erlang. RabbitMQ is an Erlang. Is that a plus or a minus?
Never crashes.
Never crashes.
I guess you could also write.
Erlang is perfect, therefore use RabbitMQ.
You could also write your own broker for ZeroMQ.
Absolutely. There is no reason why you can't write your own ZeroMQ version of RabbitMQ. Certainly you can do it. I'm not sure if you have to get to that point. Maybe you should just use RabbitMQ. I don't know. Person.
I got a question around. You mentioned that Redis also keeps this data in memory. Also, it thinks of the disk.
Yes.
It persists on the disk. Have you played around with it, or how does it keep it in sync? And like, if you start, does it actually flip on this?
So Urshan's question is about Redis and have I played around with its disk persistence? I really haven't. I've just been, I downloaded the Redis source and spooled it up and then just started using it, and I haven't dug into what happens if you take a piece out. I do know that Redis is a fairly new technology, and they're continually adding new pieces to it. For example, one of the things that they're working on is Redis clustering. So right now, some of the libraries that are talking to Redis servers have built-in sharding technology in them, and they're pulling that into Redis itself to start doing that clustering server side instead of relying on your Redis libraries to do it. Redis does have replication, so you can have master-slave replication. But as far as poking into what happens when things go wrong, I haven't touched it too much. Any question?
What is the purpose for Redis in this solution? Because your consumers can just directly connect.
Sure. So the question is, why Redis here? Why am I using this at all? I could have my commander just talking out to my processors directly and then getting the results back. I certainly could take Redis out of the equation, but I wanted to have this data persist permanently to storage so that I can come back tomorrow and see what I did yesterday, at least as an audit trail. And so I can show that actually here if I go into the Redis command line. You can see here the job results that I've been spitting back. And so I can say, I think I can do this job result of 19 of my 192.168.1.12. Let's see. So there's the JSON that I persisted for that job, and that'll be there tomorrow. Whereas if I left that out, I wouldn't be able to go back. Having that permanent audit trail for this sort of thing is absolutely necessary.
Does it keep this data in memory or just?
So Redis is keeping this data in memory, but it's also then persisting it to disk. So, so if you reboot the machine, you'll get it back within certain tolerances. Okay. And all of that sort of configuration is tunable in the Redis comp. You can start playing with how often it's going to persist its data to disk. You can, on the command line or programmatically, you can say, all right, save all of that data to disk and let me know when it's done. You can be sure if you want to take it to that level. Yeah. I think. So let's look at some code. Let's actually look at I demoed the code, but let's actually look at the code and see what's involved here. I botched it.
So perfect.
It was so perfect.
Unless you actually do show some code.
There we go. Excellent. Okay. So first of all, let's do this. So I've got my commander, my transmitter, my processors, my receiver, and that's it. Let's take a look at that. So everything that I did was 206 lines of code. And think about the networking that just went on to go from my source machine to my 3 target machines back, persist that all to disk. I say 206 lines of code is pretty stellar. Now, Urson, your point still stands. It's not great code. It's not perfectly robust.
I didn't have it in mind at all.
Yeah, you weren't thinking about it at all. But, okay, so double that up to 400 lines of code and add in some nice robustification. And that's still not a whole lot of code. So let's look at the shortest one. Let's look at the receiver. I'm going to get rid of slide that off to the right there. So I'll just look at the guts. Up top, there's some command line argument parsing that I'm not going to touch. But essentially, what I've got here on the receiver end is an infinite loop. And here's my ZeroMQ socket just waiting for data to come on in. As soon as it gets that job, then it does some JSON conversion, and then it talks back to the Redis database. So it says, all right, I'm going to set my key, and I'm going to push onto my my Redis list that this particular job is done. The commander that started at the beginning is listening for those 3 jobs to come back. So the receiver is pushing onto that list, commander popping off of that list. Really pretty straightforward code. The commander, I think, comes in as the heftiest beast, but again, there's a lot of argument parsing here. So it's simply a matter of taking those arguments and converting into a JSON format and then sending it up to Redis and forgetting about it. the guts of storing that job. It's just one line of setting my key, pushing onto my job queue. So my transmitter is listening to that job queue. I've got 3 jobs I need to do. All right, here you go, send it out. Pretty straightforward.
How'd you get the ID again?
How did I?
The job ID?
Oh, the job ID. Good question. So the job ID was created here in my create job function. I make a Redis call and I increment the job ID key. Now this is atomic, and I have to have all of my jobs to have a unique job ID. That's very important. So if I've got 2 people running commanders at exactly the same point, they've still got to get different job IDs. Redis gives us that atomic increment on this job ID field, and it returns the result to me. Yeah. All right, so my transmitter is listening to my Redis list called job_queue, just listening for those things. And then it's parsing that data, it's pulling out the hosts that it needs to talk to, and reformatting things in JSON, and then it's simply, I'm creating a socket, and I'm connecting to that port and sending the data, closing it, and moving on. The transmitter just set it and fire it off and forget it. It doesn't care whether the job gets run. It doesn't care what happens next. It should care if it can't talk to a host. So if a host goes down, then it should detect that. It should time out after a period of time, perhaps, and then talk back to the Redis database and say, hey, I can't talk to this guy. Right now, it will just do an infinite loop. But I think if let me do this. I'm going to kill my receiver. I'll set it up so it's ready to go, but it's not running yet. Okay, so I've got my transmitter running. I'm going to run this date command. The only thing that I've done is I've killed one of my processors on one of my virtual boxes. I think this will go through. Let's see. All right, so it's trying to send, and now if I fire up my processor again, it goes through. And it picked up. That's good. So a little bit of redundancy there. Not perfect all the way through, but pretty good for minimal lines of networking code that ZeroMQ lets you leverage.
Did the commander wait until he got all the results back before committing?
Yes, so I set up the commander. If we look at the commander, I essentially cheated here and said, well, I know that I'm sending my data to, let me do it over here so we can see that better. I said, I know that I'm sending the results to 3 hosts. So basically, I've got a for loop here that says, all right, for all my hosts, listen to this job result list and get 3 results back. It's cheating, but it works. Okay. The processor is really pretty simple. So all I'm doing here is listening for jobs on the ZeroMQ socket. And as soon as I got a job, I'm forking off a process. So this is susceptible to getting fork bombed. So you could potentially send 1,000 jobs and it would fork off 1,000 processes, which probably wouldn't be too healthy for the box. You know, and again, best coding practices would say, all right, limit the number of things that I can fork off, and have some method of going and killing infinite running jobs, right? So if you've written some bad code and it's just hung for whatever reason, then you should have maybe a dedicated channel that you can talk to and say, hey, kill that job. I know it's been running for 3 hours. Let's just ditch it. And then as far as running these jobs, well, depending on whether I've got code. If I've got code, then I'm transmitting the actual code. I need to persist that to disk. I just put it in the temp directory, make it executable, and then open up the subprocess and run that command, gather the results back, and send it back to the receiver. So I think that's it. So I will entertain any more questions that you might have. Adrian, I know you're digging deep into Redis Online and running some crazy queries.
I lost you.
Sorry.
But I definitely do understand.
Yeah, what particularly amazed me after I wrote this was just seeing how little it took to create something quite complex and powerful. 200 lines of admittedly beginner Perl or beginner Python, since I'm a Python programmer. I thought it was pretty amazing that I could create a networking type service and get results back. The amount of time that it takes to run these commands is just ridiculous. 0.094 seconds and that's complete circle of life. That's persistence back to the database, shelling out to or communicating to your 3 clients, getting the results back, all in 0.94 seconds. Now, granted, if we bring this sort of thing into a real-world environment, you've got real-world networking involved, and you're not talking to just the same box. You're going across the network. You're going to LA and Amsterdam, and it's not going to be so fast, but it's still going to be pretty darn fast. Currently, with our communications channels in Maestro, we're using SSH to do our communications to all of our boxes, and there's overhead involved there. Note there's no encryption here. That's probably something you want to add. At least you might say, okay, I'm willing to forego encryption, but I'm not willing to forego authentication. So you might have some sort of public key authentication scheme in there to make sure that the right people are running the right pieces of code. But bringing this into the real world should be significantly faster than the way we're doing it today. So this sort of, not necessarily this specific technology, but I think at some point in our future, Maestro 3.1 will probably move to something like this to make this sort of ad hoc shell scripting programming capability across our clusters really fast. And when you've got problems in production, really fast is a big win.
Does this have anything to do with mfind and mexec?
So the question is about mfind and mexec, and is there anything related there? So I wrote some tools which allow you to in parallel execute commands across our cluster. And the answer is no, not really. What mfind will create a fork for each of the hosts that it wants to talk to, and then it's doing the same thing. It's doing, or if you're doing, mfind itself is querying the Maestro database to populate the list of hosts. Mexec will fork and SSH to the target host to run the command that you specify. Mcurl will do the curling locally to those hosts, and it also gets some nice information back from the database so it knows exactly which ports it needs to talk to and figures that all out automatically. But the communications there are either SSH or HTTP. But I think that those technologies are actually something worth considering retaining. I really like the fact that here we use HTTP as a transport mechanism all over the place. Pardon me. Because in order to pull information, I can always rely on curl to get really useful information about what's going on in production. I would hesitate to just move all of that to ZeroMQ, because then you would have to write the equivalent of curl, write your query tool set in ZeroMQ. I would think that would not be a good idea. But as far as replacing mfind, mexec, mcurl, absolutely. Well, mcurl, just doing it a different way. You can still talk HTTP to the ad servers, but use ZeroMQ for the rest of the transport. Any other questions? Yeah?
How do you envision scaling Redis? I know it has a failover mode, as a master slave, but it doesn't.
How do I envision scaling Redis?
Yeah, because they've been talking about clustering for a couple of years already.
Sure. I don't know exactly what the roadmap is on that clustering feature. I do know that at least in Python and in Ruby, and I suspect maybe C as well, the libraries themselves have some built-in sharding capabilities using consistent hashing. So I think that it would be very possible today to set up your own Redis cluster with masters and slaves and failovers, and then split that into 4 sets of masters and slaves with failovers, and do the clustering portion in the code itself until such a time when Redis actually releases the clustering. I haven't played with the clustering technology, or in fact, I haven't even spooled up a slave and attached it to a master yet. It's not something I've done, but apparently it works pretty well.
Isn't there a server-side portion of consistent hashing for like reshuffling the data when you add new additions?
Server-side consistent hashing, like in code.
Like when, so you said that the clients have consistent hashing built in.
Yes, the clients have consistent hashing in, and I don't know if there's anything in Redis server side as far as that's concerned. It might, but I imagine that's part of the clustering. I just don't know where they are in their release cycle yet. Any other questions? All right, it looks like there's still maybe pizza left. There's definitely beer. AppNexians, please introduce yourselves to our guests. Guests, thank you very much for coming. We're glad to have you here. And if you have any more questions, I've got business cards up here. Take one. If you have more things you want to chat about, shoot me a line, and I'll get back to you. Thanks, everyone.